Hello everybody and welcome back. We're going to do a closer look at this Xeltek Superpro 6000 Universal Programmer. This was the last one to use the CX adapters. It was also known to have a power supply issue, which I'll go over once again when we get to that board, but I'm going to reassemble this, and as I reassemble this, I'm going to show you the parts up close, because I kind of brushed over them during the teardown and comparison video when I compared the Superpro 6000 with the 6100N and the 5000. So let's start with, we're going to reassemble this in reverse order. So this is the ground board, or ground driver. Focus in there so you can see this. It's pretty much the same board. I don't see any upgrades to the transistors. There's still Y1. There's really no upgrades. It's the same as the 5000. Pretty much sure these are interchangeable. Date of the board is the same. So nothing exciting. So make sure the standoffs are tight, just hand tight. You don't need to wrench them down. Then the next board is the V3 board, which that'll be over here. There's the V3 board. I'll zoom in so you can see. Any pointers on the lighting would be helpful. I'm slowly getting my new bench done. Really got to get a better camera setup, so super things are appreciated. So these are the transistors and diodes. If you mess up and blow your programmer up, those are the transistors that go bad. These transistors and diodes. The ones that say Y2 there. And those diodes. When you run the test software, it pretty much tells you what area to look at if you have a failure, which is kind of nice. I gotta do this sideways, so it's kind of awkward. So let's, a little tough. Plastic standoffs are not as good as brass. Be very, very careful. Those pins are pretty fragile. If it don't just snap in, you're doing something wrong. You're gonna bend a pin and you're gonna be hunting down issues. Okay, so we're gonna, and the last one, one of the standoffs hit the floor and went into the 5th dimension, so maybe the 6th dimension. I keep the shop pretty clean in here on the floor, so it's white, it should stand out. But yeah, these look like they're custom size. So. I will be taking the 6100 non-N apart and comparing it to the 6100N. to see what they changed between the two. I think it's going to be just the I/O board, that board. I think that's the only change. But we'll see when that time comes. That next board is the V31-72. It's this board. Let me zoom in again. I'm open to criticism, whatever. If you don't like the video, say so. If you like it, comment. I try to keep things in focus, but sometimes I get out of focus. But I do these in one take, so I don't like editing. I'm going to have to learn it one day. I learn a little bit as I go. But that's the V312 board, or pin 1 through pin 72. I really don't like these standoffs. They're just crappy. And get it in, get it straight. That one went in easy. That one went in easy. Okay, we're getting somewhere. I'm going to be a programmer once again. Okay, next board is the V1. That's this one. Remember, this is the 6000. A little bit different than the 5000. The ground driver board, I believe, was different. Or it was the same. I think maybe only the I/O and the main board. I don't remember. It'll be on the blog. But for these older programmers, people are paying way too much for them. And I mean, from the hardware, I really don't see much difference in how it would support, why it won't support more chips. So, I mean, the 6000 should support almost all the chips, the 6100, because the CPU, the MCU board is the same. The pen driver board is slightly different, but I mean, maybe the pen driver board would be the bottleneck in the system for supporting more modern chips, or they just are greedy. I think it's just the greed. Okay. Got to remember to zoom out. Wish I had a remote that I could just zoom in, zoom out. Maybe when I get a real camera. Okay. Next board is the V2. It's weird that it don't go 3, 3, 2, 1, but so this is the V2 driver board. case somebody needs a part number. Could have cleaned my fingernail, but yeah, one day Xeltek might release the schematics for these, but I highly doubt it. So let's throw some standoffs on here. Yeah, so, I mean, how'd you guys like it if I did some work on my little Cessna 150? And, because I did get my medical sign off for basic med. I met all the qualifications. I did get a referral so that I could get my test done so that I could possibly get my second class medical and fly commercially again. That would be awesome. But I don't know. How would you like to have some aviation content? Let me know in the comments. I haven't flown in about 10 years. I used to fly commercially. Oh, I really don't want to have to get the jab to go international to do what I used to do. But I will if I have to. No, I won't. Okay, next board up is the I/O board. Yeah, I will not get the COVID jab. This is the I/O board. It's got the same processor, or FPGA. I don't see really much difference. I mean, there's a difference, but well, we'll drop that board on. Getting there with that. Stack of boards, man. It's like a cake. Okay, next board is what's different than the 5000 and is pretty much the same as the 6100N is the MPU board. This MPU board has a custom FPGA there. It is a Xeltek AE81, and then you have their AE80. And this chip here is what holds the model number and serial number of the device. So on the 6100, the difference was that the only difference I could see was the tandem capacitors were a higher voltage. They were larger. All the chips, maybe the RAM was different. I'll have to look it up. but I'll do a comparison of the two on another video. Got an Atmel. Yeah, maybe I should have looked that chip up, see if it's got firmware. But it looks like we might have a JTAG port and some sort of communications port maybe, or programming port for the FPGA. Flat flex connectors. Back side of the board. So we'll put some standoffs on this one. Gonna have any extra screws? Too few screws? I don't think so. I think we're gonna have enough. I know I lost that one standoff on the last one. Okay, those are on. Gotta be very, very careful with these pins there. Okay, that is looking more and more. I still don't know what these batteries are used for. If anybody knows, maybe Xeltek can chime in and let us know, what's that battery for? I've never seen one populated. It's some sort of real-time clock, battery backup. What's this J1 header here for? Don't know. So now we start getting into the brass. That's why there was 5 in that one. Okay, then the power supply board. And I said on the 5000E, 5000, 6000E, and 6000, this capacitor, or this resistor right there, R6, it needs to be changed on most of them if you want to use the modern current production CX adapters or a Mega Magic. And if you put reverse polarity to these, you will pop some transistors on here. That on Q4, Q5, Q6. So if you do put in a center positive, you will burn those up. And sometimes this 470 microfarad 35 volt cap will pop. That's C4. So on the 5000 it was a little bit swollen, so it's just the mains filter cap. But yeah, it should be. Make sure we're all lined up here on those pins. There we go. So if you start getting programming errors on like 24, 25 volt EPROMs, it's that capacitor. Or if you get a 12 volt fail. Which I'm out, or I would have replaced it already on the 5000 before I put it back together. But that's my backup 5000, it just sits. So. Okay. Let's put the power cord back on. There we have it. We have a Xeltek Superpro 6000 reassembled, and some good close-up video for you. I hope it didn't get blurry. It might have got blurry, but if it did, oh well. So if you like this type of content, please like and subscribe. I gotta go get another coffee. Catch you later.